Hi guys, I'm so sorry I'm not here. I'll make it up to you someday next week. Today is Friday. What does that mean? It means it's August 17th and you're going to get another boring video. But good thing about videos, we just get it done, right? Start with and have the sub pass out this paper, writing parent transformation equations. Friday 8/17. This one's going to be quick. Look, nothing on the back. Oh, it's going to be 20 minutes at the tops, and then we'll be out of here. And then you guys can have the rest of the time free today. Sound good? Let's do this. It says write an equation for a function that has a graph with the given characteristics. We're just going to write equations. So it says the shape of y equals x squared, but reflected over the x-axis is shifted right 8 units. So this is a quadratic. So we're going to write a new equation. I don't care. This says write an equation for a function. Let's just change it to f of x. So we're going to take this x squared, reflect it over the x-axis. Is that negative on the outside or inside? Hopefully you're thinking outside, because it is on the outside. And shifted right 8. Oops, I just messed up. So it's going to be on the outside, but I have to use parentheses because of the right 8. It's going to be x minus 8 squared, f of x, equals. Oh, I can't even read that. Okay, I'm starting over. I'm going to get another paper. I just happen to have one right here. I'm throwing this away. Oh, it's so messy. I'm doing it again. Friday, 8/17. So let's try this again. F of x equals, okay, reflection over the x-axis goes on the outside. Because it says write 8 units, that has to go on the inside. X minus 8. Square goes on the outside. And that's how you would write it. The second one, what is that called? Square root function or radical function. You're going to shift it left 6, that goes on the inside of the radical, and down 5, that goes on the outside of the radical. So left means you're actually going to put a plus 6. So it's going to be f of x equals square root. So inside is going to be x plus 6. That's what left 6 looks like. And then down 5, put it on the outside of the radical. And you're done. The shape of an absolute value function. This is an absolute value, number 3. Left 7 up 2. Left 7 would be plus 7, right? Up 2. Done. Can you guys see that? Is that too small? What's this called? Y equals x cubed. Reflected over the x-axis, that goes on the outside, and then shifted right 5, that goes on the inside. So let's see here. So we have a reflection over the x-axis, so that goes on the outside. But because we have a right 5, we're going to put the cube on the outside of the parentheses, and we're going to write x minus 5 for right 5. How you guys doing? I'm going to try the next one. The next one is called the reciprocal function. Look on the board at your papers you did. Find the reciprocal function. It kind of looks like this. The reciprocal function looks like this. It has 2 curves, has a vertical asymptote and a horizontal asymptote. It has that means anytime x comes to 0, it's undefined. That is undefined at the y-axis here. Anyway, if it's shrunk vertically, that means the number outside of it is smaller than 1. So that's why it says by a factor of 1/2. So we're going to have f of x, and this 1/2 is going to go on the outside because it says vertically. Vertically is always outside. Shift it down 3, and that's always on the outside of that too. So we're going to say, all right, so we have 1/2 times 1/x down 3. So what's a better way of writing that? F of x equals 1/2x minus 3. Let me think if I like that or not. Yep, I like it. Okay, 6. This is quadratic. Shifted right 6 up 2. So right 6 looks like this. That's right 6. Up 2 looks like this. 7. This is quadratic. Reflected over the x-axis, that's a negative on the outside. Shifted right 3, that's a negative 3 on the inside. And up 4 means that's an up 4 on the outside. So we have 3 things here. First on the outside, parentheses squared. And there's your up 4. It's that right 3, you have to be careful. Right 3 is x minus 3. 8. Absolute value function. Stretched vertically by a factor of 5. That goes on the outside. 5, absolute value. And then shifted down 4. That's it. 9, square root function. Reflected across the y-axis. Now this, you have to be careful here. If it's reflected over the y-axis, the negative goes on the inside in front of the x. So it becomes the coefficient like this. But here's the tricky part. Shifted left 2. So you can't just put plus 2. Shifted left 2. Now, you can't put a plus 2 as long as you put parentheses. And then down 4. Now, if you take this down here, if you would have distributed the negative, it would look like this. Anytime you have a function like this, what you have to do is you have to take the negative out and write it like this. So when you're reading this, this is a reflection over the y-axis, left 2, down 4, which is what these things say. So this is correct and this is correct. But you cannot just write negative x plus 2. That would be wrong. And then the reciprocal function, reflected across the y-axis. So the negative has to go with the x. Because fractions, typically there are parentheses already here and here, you'd put this negative here for the reflection across the y-axis. And then up 7 would be outside. That's how you're supposed to do it. Those are done. So write the equation for the graph of a function. This is a v. Which one? Look on the board. Which one of them looks like a v? Hopefully you're thinking the absolute value. So here's the parent graph. Absolute value. So it has to look something like that. So originally it starts at 0, 0, correct? This one is actually right 2. And then usually an absolute value function goes up 1 over 1, up 2, up 2. So it looks like everything else is good. It just looks like it went right 2. That's it. So you're going to write g of x. Right 2 means this. Try graphing that on your graphing calculator and see if your graph is correct. See if it matches that one. That's how you kind of double check it if you're on a test. See if you're right. This is the reciprocal function. The parent graph of this is 1 over x. Now typically the vertical asymptote's right here, but it looks like to me that the vertical asymptote's at 2, which means to me that it was shifted right 2. But the horizontal asymptote is usually at 0, 0 also, and it looks like that was shifted down 1. So those, if you can actually draw asymptotes in, and that helps you tell what the shifts are. So the vertical asymptote is originally the y-axis, and it shifted over 2 to the right. So if you're shifting something 2 to the right, it's got to kind of go with the x. 2 to the right looks like that. Then it went down 1, and that goes on the outside. And that's your answer. This one is cubic, but let me show you what a cubic usually looks like this. So this one's been flipped. Like this part's down here and this part's up here. That means there was a reflection over the x-axis, which means there's a negative on the outside. It also looks like it went down 2. Do you see that? Now there's a point here, here, and here. So the three amigos look good. They're all 1 apart. But it looks like it went down 2. And it looks like it was reflected over the x-axis. Take a second to look at that. Do you guys look like it? Does it look like it was reflected from this one to this one. And see how it was at 0, 0, now it's down here at 0, -2. So that means down 2. So how do we write this? So it's cubic down to reflected over the x-axis. The negatives on the outside. X cubed down 2. Try it on the graphing calculator, see if we're right. Let's say this one. This is what I mean by try it on the graphing calculator. So you go to the graphing calculator, and you're going to go negative x to the third, like that, minus 2. And you're going to graph it. Does it look like the graph that's on there? Let's look at the t-table, second graph. I see a 0, -2, boom. I see a 1, -3, boom. I see a -1, -1, boom. All right. There it is. I can just double check it on the graphing calculator. Should we double check that first? This one right here. Let's look at that one. 1 divided by parentheses x minus 2 minus 1. Is that right? That kind of looks like that, right? Yeah, boy. And then let's do the first one. Maybe you don't even know where the absolute values are. To do absolute values, there's a couple ways to find it. One way is just pressing math and then going over to number, like right there, up there at the top, and then absolute value is number 1. That's where I always get it. And then you just do x minus 2 and graph. And it should be this one right here. Okay, so this one looks like a square root function that has been reflected over the x-axis. So usually it looks like this, over 1 up 1 and over 4 up 2. Look up on the board, that's what the parent graph looks like. You can't see what I'm doing right now, so let me show you. This is the parent graph. 0, 0, over 1 up 1, over 4 up 2, because the square root of 4 is 2. So this point right here, it looks like it's 0, 0. It looks like it's 1, -2. It looks like it went over 1 down 2, where this one's over 1 up 1. And then this one looks like it's over 4 down 4. Usually it's over 4 up 2. So it looks like it has a vertical stretch of 2. Because the y's are, instead of being 1 apart from the x-axis, it looks like it's 2 apart. So it's double the distance. You see that? This has a distance of 4, and this only had a distance of 2. So the vertical distance from the x-axis is double what it was when it was above. So that means it's a vertical stretch. And it's by a factor of 2 because it doubled it. It's also got a reflection over the x-axis. So how would we write that? Well, the original looks like this. That's the original. You see that? Let me move this. The original is right here. F of x equals square root of x. So a vertical stretch of 2 means out there. Also, the reflection of x-axis is also out there. So this is what you would have. I'll write these in blue. Okay, 15. What are you noticing about 15? To me, it's an inverted quadratic. Quadratics usually are start at 0 and go over 1, up 1, and over 2, up 4. That's what they usually look like. So it looks like it went up 1, and then it went upside down. It looks like everything else is the same. So it looks like it was inverted, so we're going to go f of x equals. So first, because it went upside down, the negative's on the outside. And then it went up 1. That's it. This one is the square root. And again, here's the square root again. That's what a square root looks like. This one's going the opposite direction, which means it's a reflection over the y-axis. So here's what it looks like originally. Since the reflection over the y-axis, the negative's going to go on the inside like that. And then it looks like I went down 2. Make sure that negative's on the inside. Okay, guys, 15 minutes and we are done.